Hello everyone, welcome to another video where we'll be discussing about we'll be solving numericals. Okay, and this will help students who are going to appear for class 12 board exams. Right. So this topic we'll be discussing first about capacitance. Okay, capacitance. We'll be solving some questions on capacitance first, then we'll proceed. Okay. Yeah. Can you please write the questions along with me? Otherwise, you won't find it helpful. The electric field. The electric field between the plates of a parallel plate capacitor between the plates of a parallel plate capacitor of of capacitance 2 microfarad drops to drops to one third drops to one third of its its initial value in 4.4 microsecond when the plates are connected by thin wire. When the plates are connected by thin wire, find the resistance of the wire. Find the resistance of the wire. The electric field between the plates of a parallel plate capacitor or capacitance 2 microfarad drops to one third of its initial value in 4.4 microseconds. When the plates are connected by thin wire, find the resistance of the wire. Okay, try this question. First try. First try, then only I will solve. Electric field between the plates of a parallel plate capacitor. Parallel plate capacitor. Electric field between them, like they are 2 microfarad, drops to one third of its initial value in 4.4 seconds. That means E dash becomes E no E by 3. E is the initial value in 4.4 seconds. T is equal to 4.4 microseconds. When the plates are connected by thin wire. Okay, if I connect the plates by thin wire, the electric field reduces to 1 by 3 of its original value. Okay, find the resistance of the wire. That is the question. Okay, so this is not a direct this. For this, you need to know the formula of electric field. Hmm, right. Formula of electric field is, see, when these two wires will be connected by a thin wire, your charge, okay, your charge will reduce also. Like the formula for it is the change in charge. That is it. Like that Q is equal to Q naught e to the power minus T by RC. This is one formula you need to remember for this. Okay. So our formula for electric field is what? E is equal to Q by A epsilon naught. Q by A epsilon naught. Now Q is what? Q naught by A epsilon naught e to the power minus T by RC. Alright. Hmm. Now this thing can be written as what? If Q by A epsilon naught is E, Q naught by A epsilon naught can be what? E naught. Okay. E naught e to the power minus T by RC. So E is equal to E naught e to the power minus T by RC. Okay. So here what is the question? Electric field is reducing to 1 by 3 of its original value. For example, this is the original value of electric field, E naught. E naught is the original value. Okay. So E is equal to E naught by 3. Okay, so in place of E, we can put E naught by 3 is equal to E naught e to the minus T by RC. So E naught cancelled out. So 1 by 3 is equal to e to the power T minus T by RC. So if I take what will happen? This E will come to this side, become ln. Okay, ln 1 by 3 is equal to minus T by RC. Now this minus will come to this side, minus ln 1 by 3 is equal to T by RC. Minus ln 1 by 3 is or ln 3, isn't it? So ln 3 is equal to T by RC. What is the question? Find the resistance of the wire. Resistance. So resistance, I can take resistance to this side and ln3 to that side. So T by C ln3. Now T is 4.4 microseconds and C is what? 2 microfarad into ln3. ln3 is, what is ln3? ln3 value is 1.1. Okay, remember that 1.1. So you can see this cancelled out. This is 4, this is 2. Okay, so resistance is what? 2 ohm. ln3 is equal to 1.1. ln2 is equal to 0.692. You know these values. How to convert ln to log? 2.303 log. Give me ln. Okay, got it. Okay, I hope you understood this question. Just have to remember that when this wire is connected, and there is a reduction in electric field or charge, the formula will be like reduced charge will be Q is equal to reduced charge. Q is equal to Q naught e to the minus T by RC. Electric field is Q by A epsilon. That is the formula. Okay. So this Q naught by A epsilon naught can be written as E naught. So in that way you can proceed with this question. Question number 2. Question number 2. A capacitor is connected. Capacitor is connected to a 12-volt battery. 12-volt battery through a resistance of 10 ohm. Resistance of 10 ohm. It is found that the potential difference is found that the potential difference across the capacitor potential difference across the capacitor rises to 4 volt in 1 microsecond. Find the capacitance of the capacitor. Find the capacitance of the capacitor. The capacitor is connected to a 12-volt battery through a resistance of 10 ohm. It's found that the potential difference across the capacitor rises to 4 volt in 1 microsecond. Find the capacitance of the capacitor. Okay, rises to this. Hmm. So how to solve this question? See here, potential difference across the capacitor rises to this. That means what? That means this is in charging state. Okay, that means the capacitor is charging. So what is the formula? So write down charge on the capacitor during charging. During charging is Q is equal to Q naught 1 minus e to the power minus T by RC. Okay, remember this formula. This is during charging. The previous question we did what? This is reduction. That means this is during discharging. You can say. So discharging Q is equal to Q naught e to the power minus T by RC. Charging it is Q is equal to Q naught e to the power minus T by RC. Okay. Now potential difference will be what? Potential difference across the capacitor. Potential difference across the capacitor. Across the capacitor. V is equal to Q by C. That is Q naught by C 1 minus e to the power minus T by RC. Okay. Hmm. Now Q naught by C is what? V naught. I can write V naught. So V is equal to V naught 1 minus e to the power minus T by RC. Now all the given values are there. Now your potential initially was 12 volt in the question. 12 volt, right? 12 volt. And then it was 4 volt. This would be 4 is equal to 12 1 minus e to the power T by RC. T is a 1 microsecond minus 6. Okay. Otherwise, do one thing, let it be like this. Minus T by RC. So 4 is equal to 12 minus 12 e to the power minus T by RC minus 8 is equal to minus 12 e to the power minus T by RC. 8 by 2 is equal to e to the power minus T by RC. Okay. ln 8 by 12 is equal to minus T by RC. ln 12 by 8, I just reciprocated it. The minus will go away because minus ln, I just took the minus to this side, is equal to T by RC. So minus will do this reciprocate, like it will reciprocate this. Right. Yeah. Now what? ln, if I do it, it will be if I 4, if I divide it by 4, 3 by 2 is equal to T by RC. Now ln 3 is ln 3 minus ln 2 is equal to T by RC. We just did in the previous question. ln 3 is 1.1, ln 2 is 0.692. T by RC. If you subtract this will be around 0.405 is equal to 1.1 something. Okay, this one. It's T by RC. T is a 1 microsecond, minus 6. RC. Okay. R is your what? What is R in the question? R is 10 ohm, right? 10 to C. So just C you have to find out. Okay. Calculate yourself. See. You get the question. Okay. So question number 2. Question number 3. Similar type of question. Do a capacitor charged to 50 volt. This one you do yourself. I have done two questions related to this. Capacitor is charged 50 volt. Capacitor charged to 50 volt is discharged by connecting the two plates. Connecting the two plates at t is equal to 0 if the potential difference across the plates drops to 1 volt at t is equal to 10 millisecond. What will be the what will be the potential difference at 20 millisecond? What is the potential difference at 20 millisecond? Try this question. You try this question. You have 5 minutes. You should be solving this in 2 minutes, but just give it 5 minutes and try. You can pause the video if you want. Okay. If you want to solve, please pause the video. So potential difference at time t is what? Again, same kind of thing. This is your what? Discharging. We know during discharging it will be what? V is equal to V naught e to the power minus t by RC. During charging it will be V is equal to V naught 1 minus t by RC. This is how you have to remember it. So this is discharging case. Okay. So V is equal to V naught e to the minus t by RC. Yeah. From the given data, like it becomes 1 volt at 10 millisecond. Right. It was earlier 50 volt. So V naught is 50 volt. V naught is 50. V naught means capacitor in the beginning. At t is equal to 0, this is V naught. But it is changed to 1 volt. That means this is V. Okay. So V is 1 volt. V naught is 50. So 1 is equal to 50 e to the power t minus RC. Same kind of thing again. So 1 by 50 is equal to e to the power minus t by RC. Ln 1 by 50 is equal to minus t by RC. So t by RC is equal to ln 50. Yeah. Right. T by RC is equal to ln 50. So this is you can say, see, this is t. This is when t is 10 millisecond by RC is equal to ln 50. So RC can be written as 10 millisecond by ln 50 is equal to RC. Right. Now what will I do? We are asked like what will be the potential difference at 20 millisecond. Okay. Okay. 20 millisecond we are asked. So what will I do? Potential V is equal to V naught. Okay. E to the power minus t by RC. Now at 20 millisecond, that means now t becomes 20. And what is V naught now? Can you tell me what is V naught now? See, first V naught was, yeah, V naught is 50 volt. So I can put it here 50. E to the power minus t by RC. Minus t is minus 20 millisecond here in this case into 1 by RC. That means by RC. So 50 into e to the power minus 20 millisecond. What is RC? RC is 10 millisecond by ln 50. So I can put it here. 10 millisecond by ln 50. So this can be 50 e to the power millisecond cancel 10 10 2. This ln 50 it will go up, isn't it? It's divided. So minus 2 into ln 50. Yeah. Now see 50 into e to the power. I can take the minus 2 to here because x ln y can be written as ln y to the power x. This thing will go and become the power of y. So e to the power ln 50 to the power minus 2. Yeah. Now another property will be here. E to the power ln x is simply x. If this is ln, this is e, this is ln, then this whole thing will vanish and it will be x only. So e to the power ln 50 to the power minus 2 is 50 into only this thing will be left. 50 to the power minus 2. Okay. 50 to the power minus 2 means what? 50 into 1 by 50 to the power 2. The answer is 1 by 50. That is what? 0.02 volt. Okay. This is the final answer. These properties, I hope you know these properties. Alright. And you just have to use them. Right. Just see through this question again. Let me know if you understood or not. Okay, done. Next question. See, these are the good questions, standard questions of capacitance. Capacitance questions you can do also, like everything will be given, you just have to find the values. Those questions are, see, anyone can do those questions. So it's better to do questions that are like new, that will like challenge you a bit. Hmm. And these questions are like that. I've done three the same type of questions, so I hope you can now solve this type of questions. Another one, this one is a bit another different kind of question. Question number 4. Question number 4. A 5 microfarad capacitor having a charge of having a charge of 20 microcoulomb 20 microcoulomb is 20 microcoulomb is discharged discharged through a wire of resistance 5 ohm, resistance 5 ohm. Find the heat dissipated. Find the heat dissipated in the wire Find the heat dissipated in the wire between 25 to 50 microsecond after the connections are made. After the connections are made. 5 microfarad capacitor having a charge of 20 microcoulomb is discharged through a wire of resistance 5 ohm. Find the heat dissipated in the wire between 25 to 50 microseconds after the connections are made. Okay, this is again the case of discharged. Okay, this is discharged through a wire of resistances. So again, the formula will be: read the question first two, 3 times, and then pause the video, try yourself. Otherwise, there is no point. Charge on the capacitor at T after connections are made. Okay, Q is equal to Q naught e to the power minus T by RC. Okay, find the heat dissipated in the wire. Heat, to calculate heat, we need current. Okay, so what is current? Current is dq by dt. Hmm? So d by dt of Q naught e to the power minus T by RC. Q naught comes out, so d by dt of e to the minus T by RC. So minus Q naught by RC is the minus T by RC. This is your I. Okay. So heat dissipated is what? Heat dissipated during time T1 to T2. T1 to T2 will be what? Heat formula is H is equal to I square RT, I square R dt, T1 to T2. Okay. So I we got was minus Q naught by R, so Q naught square by R square C square e to the power minus 2T by RC into R dt, T1 to T2 integration. Yeah. Why we are doing this? Because this is a variable in T, so we have to do this way. So R got cancelled. Now this constant will come out Q naught by RC square T1 to T2 e to the power 2T minus RC dt. Q naught square by RC square, and the integration will be minus T minus 2T by RC all divided by minus 2 by RC T1 to T2. Okay. So minus Q naught square by RC into RC by minus 2. So divided e to the power minus 2 T2 by RC e to the minus 2 T1 by RC. So RC is what? R and C are given. So you can say R is 5 ohm. C is your here 5 microfarad. So RC is your 25 microseconds. Okay, RC has the unit of time. Okay, T by RC. So the numerator is T time. So the denominator should be also time. So T RC is 25 microseconds. Okay, so this is your T1. T1 is your 25 microseconds. We know. And the other one T2 is a 50 microsecond. That's given in the question. From T 25 to 50 microseconds. So we just put it in the formula. So, uh, so H is equal to, what is it? RC got cancelled here. Q naught square by 2 e to the power minus 2T2 by RC minus is there, minus e to the minus 2T1 by RC. Let's put the values. Q naught square by 2 minus T2, that means 100 by RC is your 25. E to the minus 100 by RC is, sorry, this is used to be 50 by RC is 25. This is 4, this is 2, minus goes in, Q naught square by 2, e to the power minus 2 minus e to the minus 4. So Q naught square by 2, 1 by e square minus 1 by e to the 4. Okay, so Q naught is how much? Q naught is your 20 microcoulomb given in the question. 20 to the minus 6 square by 2. This is 1 by e square minus 1 by e fourth. Okay. So e value is 2.7 or something, and you just start to put it there and get the, otherwise you can leave it that way if the options are given, or like if it's a 2 mark question, otherwise you have to calculate the square and the fourth. Okay, you have to do it. It won't come like this in the exam, but still, in case. I hope you understood this question. Again, a different type of question, and we should be solving this type of questions, not like everything is given, Q is given, V is given, you just ask C. No. Okay, next question. So question number 4, I think. Yeah. Question number 5. Question number 5. How many time constants? How many time constants will elapse? Will elapse before before the energy stored in the capacitor, energy stored in the capacitor, energy stored in the capacitor um, drops to, wait, um, again write it. How many time constants? First, do I have to do another question? How many time constants will elapse? Will elapse before the current for the current in a charging RC circuit drops to drops to half its initial value, half its initial value. Okay. Great. How many time constant will elapse before the current in a charging your RC circuit drops to its initial value? Time constant. How many time constant? Time constant means what? Time constant is your RC. So how many RCs will be there? That means the value of RC. Alright? No, sorry. Time constant T by RC. Sorry. T by RC. Tau. Tau is T by RC. This is your time constant. So what is the value of tau? What is the value of T by RC before the current in a charging RC circuit drops to its what initial value, half of its initial value. That means initial value is suppose Q naught. Current I naught. So I naught will drop to I naught by 2. So if I write the equation I is equal to I naught, sorry, I is equal to I naught e to the power minus T by RC. So I is I by 2, I naught by 2 is equal to I naught e to the power minus T by RC. Okay. So this is your I naught cancelled. 1 by 2 is equal to e to the power minus T by RC. Yeah. Right. So this is ln. 1 by 2 is equal to minus T by RC. Okay. Minus will come to this side. It will become minus ln 1 by 2 is equal to T by RC. So T by RC is what? ln 2. Which is in fact the answer because this is a time constant is asked. Tau is equal to ln 2 which is 0.693. Okay. So see this same type thing but different varieties we are just doing. Okay. This is for what? Discharging. That's why I do this equation. This equation is for discharging. For charging there will be 1 minus this. Hmm. Alright. Next question right now. This is question number 5. Question number 6. Again, same thing. How many time constants? Try this one. How many time constants will elapse? Okay. Before the power, before the no, charge on the capacitor falls to 0.1% of its maximum value, 0.1% of its maximum value, 0.1% of its maximum value in a discharging RC circuit. You try this one. It's your homework. Okay. Also write another homework. This is one homework. Another homework number 7. No, leave it. Only do this one. Alright. So these are the types of questions from capacitance that will come. Okay. Hope you understood. And yeah, keep tuned to the channel for more numerical sessions like this. Okay. Thank you very much.